Hello, welcome to the third unit, matrix decomposition and pseudo inverse of a matrix. In this video, we are going to see the Moore Penrose pseudo inverse of a matrix. Moore Penrose pseudo inverse of a matrix. So before going to see the pseudo inverse of a matrix, let us see what is meant by full row rank and full column rank. Okay, so first we'll see row rank. So full row rank is simply known as row rank. Suppose rank of a matrix of order m by n, a matrix is there whose order is m by n. So if the rank of this matrix whose order is m by n is equals to the number of rows in the matrix, then the matrix has full row rank. The meaning is here. So suppose A is a matrix whose order is 3 by 2. Suppose if its rank is 3, then we say that it is having full row rank because the rank is equals to here the number of rows. So in another way also you can see the row rank. The number of linearly independent rows are equals to the rank of the matrix, then the matrix has full row rank. That means in that matrix, if the number of linearly independent rows are equals to the rank of the matrix, then also we'll say that it is full row rank. Similarly, full column rank. So rank of a matrix of order m by n is equals to the number of columns in the matrix, then the matrix has full column rank. Or in another way, number of linearly independent columns are equals to the rank of the matrix, then we say that it has full column rank. Now, sometimes it may be rank deficient. What is rank deficient is rank of a matrix of order m by n is less than the number of rows and columns in the matrix, then the matrix is rank deficient. For example, suppose A is a matrix of order 3 by 2 and we calculated its rank and we got the rank is 1. So 1 is clearly less than the number of rows, that is 3, and the number of columns 2. Then we say that that matrix is having rank deficiency. Okay, so that is the meaning. Now we will come to Moore Penrose pseudo inverse. So what is the use of this Moore Penrose pseudo inverse is, generally we'll calculate inverse for square matrices only. We don't see the inverse for rectangular matrices. So this is a procedure to calculate the Penrose in Moore Penrose is a procedure to calculate inverse for rectangular matrices. Okay. So in mathematics and in particular linear algebra, a pseudo inverse will represent with A plus. Generally inverse will represent with A minus 1 type, right? A power minus 1. So here the pseudo inverse will represent with A power plus of a matrix A is a generalization of the inverse matrix. The most widely known type of a matrix pseudo inverse is the Moore Penrose pseudo inverse. So a common use of this pseudo inverse is to compute a best fit, that is least squares solution to a system of linear equations that lacks a unique solution. We'll see this in the next video. Okay. So the pseudo inverse is defined and unique for all matrices whose entries are real or complex numbers. Matrix inverse exists for square matrices only. Real world data is not always square. Furthermore, a real world data is not always consistent and might contain repetitions. So to deal with real world data, generalized inverse for rectangular matrices is needed. So it can be computed using the singular value decomposition also. So the procedure is like this. Let A be a matrix of order m by n. Then the pseudo inverse of this A will calculate like this. Suppose this matrix A, right? For this matrix A, if the columns of the matrix A are linearly independent, right? Suppose the columns of the matrix A are linearly independent, then the pseudo inverse of A is, we'll use this formula. A plus equals to A transpose A inverse multiplied with A transpose. Suppose if the rows are linearly independent, then the pseudo inverse formula is the second one. Suppose if the matrix has rank deficient, then we will use, to calculate the pseudo inverse, we will use the singular value decomposition. We will take the help of singular value decomposition and we will calculate its pseudo inverse. Okay, and here while calculating here, see, if you see the pseudo inverse, u sigma v transpose a plus is nothing but here inverse only. So what is this one? V transpose inverse sigma inverse u inverse. V transpose inverse is V because V is an orthogonal matrix, right? So V transpose is nothing but V inverse. V inverse whole inverse is V. So sigma inverse as it is. U inverse is nothing but U transpose here, because what is U? U is also an orthogonal matrix. So for orthogonal matrix, its inverse is nothing but it's a transpose only. So when you are using singular value decomposition, we'll use this formula to calculate the pseudo inverse. So here, what is sigma means? Sigma we know how to write in the descending order. The biggest value of eigenvalue we have to write here, the second biggest. So in this case, sigma inverse means its reciprocal, so you have to write. Now we'll see the problem. Find the pseudo inverse of A equals to. So if you look at this matrix, it is a rectangular matrix, it is not square matrix. Now we'll see how to calculate the inverse. So before calculating the inverse, first we have to calculate its rank. So the given matrix is this one. So I am taking one minor here, 1 2 4 3, so which is clearly not 0. So that means its rank is 2, because if you are able to find at least one minor whose determinant is not equals to 0, then we can declare that the matrix is having rank of that order. So in this case, I am successful in calculating the rank. So rank is 2. Next, since for the given matrix rank, this rank is equals to the number of rows. How many rows are there here? 2 rows are there. This matrix is of order 2. In the beginning, we have seen the definition. This matrix order is 2 by 4. That means 2 rows are there and rank is 2. Therefore, it is having, according to the definition, it is having, so see here, since for the given matrix the rank is equals to the number of rows, therefore the matrix has row rank, which implies rows are linearly independent. So whenever it is having row rank, we have seen the formula is this one. So whenever it is having the row rank, the formula is this one, A transpose into AA transpose inverse. That is the formula. So that is A transpose into AA transpose inverse. So A is given, calculate its A transpose, multiply, we'll get a matrix here. Next, we need its inverse, right? So take its determinant and use the inverse formula, 2 by 2 matrix inverse formula, 1 by det A, 15 into 30 minus 15 into 15 plus interchange this 30 and 15 and this, change the signs here. So this is the inverse we got. So finally, the pseudo inverse is, the formula is A transpose into A transpose, this one, A transpose inverse, just now we calculated. If you multiply, you will get this one. So this is the inverse of the rectangular matrix. Okay. Next, find the pseudo inverse of A. So this is also a rectangular matrix, but the order is here 3 by 2. So we are calculating its rank. So rank is here 2. But 2 is equals to, in this case, number of columns. Therefore, it is having the column rank. So when it is having the column rank, the pseudo inverse formula is A transpose A inverse into A transpose. In the beginning, we have seen this formula. So we require A transpose A. We calculated here, and its inverse is calculated because 2 by 2 matrix inverse is very easy. Then multiply and we will get this one. This is the pseudo inverse. Now we'll see the third type problem. So here the matrix order is 2 by 3, which is a rectangular. So first I am calculating the rank for this one. So this is the matrix. If you see clearly, according to rank, the matrix is here order is 2 by 3. Therefore, the rank for this matrix is, it must be either 2 or 1, okay, but not equals to 0. But here we are not unable to find any 2 by 2 minor. If you take this one, 4 minus 4 0, 12 minus 12 0, first and last also 6 minus 6 is 0. So there is no second order minor is possible. Therefore, the rank of this matrix is 1. So clearly 1 is less than the number of rows as well as number of columns. Therefore, it is rank deficient. So whenever it is rank deficient, you have to calculate its pseudo inverse with the help of SVD formula. So this is the SVD formula we are using. To calculate pseudo inverse, you have to use this formula. So we know how to calculate pseudo inverse, right? So the matrix is this one. So in order to get V, first I have to calculate A transpose A. So this is A transpose A, and the eigenvalues we got is this one, and the corresponding eigenvectors is this. So the singular values is this one, and the normalized eigenvectors is V1, V2, V3, and from that we will get V, and sigma is, we have to construct sigma by taking the largest value here, next 0, next 0, and u1 u2 using those two formulas, because this procedure already we have seen u1 and u2. So from that you will get u. So therefore A plus equals to, the formula is V sigma plus u transpose. So V is this one, right? And plus sigma plus is nothing but its inverse. How to calculate its inverse? You have to take its reciprocal. So 1 by root 70, 0, 0, 0, 0, 0. Okay. So this is its reciprocal. Okay. That we have seen here. Followed by u transpose is this one. Okay. So if you multiply, you will get this one. So this is the way of calculating the pseudo inverse of your rectangular matrix. So we have seen three types. One is column rank, another one is row rank, another problem is rank deficient. Okay. So I am Srikanth Reddy. Thanks for watching. I will see you in the next video.